Okay, so yesterday I told you something important about solving logarithmic equations. Does anybody remember what that is? When I solve a logarithmic equation, what do I have to make sure of? That's it, exactly. No more than one logarithm on each side. So when I look at the first problem on this practice thing, what's wrong with it? There's two logarithms right there. So what am I going to have to do since there's two of them? Andrew, what are you doing on that iPad?
I was exiting off all the things that I had.
Okay, well if it's not math, let's get rid of it. Okay, we really don't need it unless we're taking notes on it. How do I put those two logarithms together? It becomes a division problem, so it'll be the log of x plus 2 over 3 equal to 2. Right? Then what?
Then you do 4 plus, or 4 to the power of 2 equals x.
Exactly. Very good. We translate this from the logarithmic equation into its exponential form. 4 to the second equals this. Beautiful. Then we just solve. So we just got a regular equation now. So 48 equals x plus 2. And it looks like x is 46. Would you agree with that?
Yes.
And then what do I always have to do? Just stand back quickly and do what? Check and make sure that when I put it back into the equation, this is positive. It is, so I'm good. That's my answer. Now, what about number 2? It's a more complicated looking equation.
First, get one logarithms.
So look at all those logarithms. There's a zillion of them. Okay, so what am I going to do? See these two right here? You can't have two. You can only have one. So what are we going to do? We're going to put them together, and they're going to go together as a multiplication. And over here, ooh, we got two problems over here. See that right there? You got to do something with that. What are you going to do with that 2? It becomes an exponent. So that'll be the log base 6 of 16. 4 squared. Now, you've got 2 here. You're not allowed to have 2. What are you going to do with that? You're going to create a division problem. Everybody okay with that? Now, that's a different scenario than we had over here, groupies. Over here, when we combined our logarithms, we got this. You see how there's only one logarithm in this problem? Over here, we have logarithms on each side. Now, we only have one on each side, but we have them on each side. So the way we handle that is going to be different than how we handled this one. How we handled this one is we rewrote it as its exponent form. 4 to the second equals this. What do you think we're going to do with this? I want you to think about this for a second. Michael says, can you just cancel the logs? It's not really canceling. Think about it for a second. If the log in this hand is the same as the log in this hand, don't these two things have to be the same? So we're not really canceling, we're just using our common sense and saying, wait a minute, if the log of this is the log of this, then whatever 3x is, it has to be 16/5. It's not like we're dividing both sides by log 6. You can't do that. It's just common sense. These two things have to equal. If their logarithms are equal, they have to be equal. So What am I going to do to solve this? It's got a fraction in it. Multiply by 1/3. So the answer is 16/15. Now do stand back and make sure when you put that in, it stays positive, and it does. This has to be positive. Everybody okay with that? Number 3, write as a single logarithm. So in other words, so how do you want to start this one? Any ideas? I'm sorry it's so cold in here. I don't understand it. Because when I came in here earlier this morning, it was like normal. I don't know why it's so cold all of a sudden. Anyhow, anybody have an idea how to start?
Use a multiplier first.
Okay, we can't multiply and divide first. First we got to deal with these. These guys have priority. They have to be managed first. And if you think about just your regular order of operations, not like PEMDAS, we do exponents before we do multiplications and divisions, right? These are exponents, so they have to come first. So this would be the log of x to the 4th minus the log of 8, and then plus the log of 7. Now we're going to write that as one giant logarithm. Is this thing going to have a division in it? Yes. So we're going to have an x to the 4th divided by an 8, right? What do I do with the 7?
Goes on top.
It goes on the top. There's your answer. Why does it go on top? Because it is a multiplication, not a division. You okay with that? All right, and then the last problem. Now, this one requires you to think a little bit. Given this information, this is just made up information, we are going to find the log of 3b over 2. Anybody have an idea? We've not practiced anything like this. Anybody have an idea how that might work? Tom?
Do you put it in exponential?
Well, we could. Here's going to be the issue with that. In order to do that, I'd be introducing yet another variable. Because you're saying rewrite it as b to the x equals 3b over 2? Yeah. And I mean, certainly that's not wrong. I don't know where to go from there. Do you have a thought? It's a good guess. When you're in doubt, doing what he suggested is always, always a viable option. Or it's an option. Whether it's viable or not is another story, but it's always an option. Could this be broken apart? This is a division and a multiplication, right? So how would that look if we broke it apart? It'd be the log base b of what? 3 plus the log base b of b minus the log base b of 2. Now wait a second, does everybody see a multiplication here? And a division? So when I pull that apart, it's the opposite of what we did over here. Over here we glommed it all together. Now we're pulling it apart. So this pulls apart as an addition and this pulls apart as a subtraction. You okay with that? So what's the log base b of 3? Well, they told me that's 0.2. Oh. What's the log base b of b? 1. Very good. The log base b of b to the first, kids, is 1. That's one of our properties. They don't tell me that. That's not in my list. I'm supposed to know that. And the log base b of 2 is 0.1. So our answer is 1.1? You okay with that? Let's try another one like that. That's a good problem. Let's try something similar. How about use the same given? Let's use the same given. What if I ask you to find the log base b of b squared root, say, 4th root of 6. Oh boy. Using that same given right there. Ideas? Let's start the same way. Let's see if we can tear it apart. Can we tear it apart? What would it look like if I tore it apart? Log base b of b squared plus the log base b of the 4th root of 6. Now this you ought to know already. What's the log base b of b squared? That's 2, so we just got a 2 there. What about this? Yeah, that's to the 1/4 power. We do not mix radicals in logarithm land, so that's going to be 6 to the 1/4. Now wait a minute. What do I do with that 1/4? It comes out in front, so I'll have 1/4 log base b of 6. What am I going to do with that? Make it, no, it's not 2 cubed. What's 6? Not 2 cubed. 2 times 3. So I'm going to rewrite the 6 as 2 times 3. Now, for those of you that are wondering, why are you doing that? Keep in mind that that's the only given I had, right? These are the only numbers I have information about, so I need to rewrite my problem. Now, what am I going to do now that it's the log of 2 times 3? What am I going to do with it? What's that going to, break that apart for me. What will that be? The log of 2 plus the log of 3. So 2 plus 1/4 times, these numbers I knew, that's 0.1 plus 0.2. These were given. So 2 plus 1/4 times 0.3. So 2 plus, okay, that's 1/4 times 3/10. So 3/40ths. So 2 3/40ths, whatever decimally that is, that's your answer. Anybody have a question about any of that? Okay. All right, let's have questions then about, hang on to this packet because we may have time to do a few more. There's a lot of stuff on here. Get a chance to do a few more. Any questions about any homework up until this point in this chapter? Any questions? Delaney, give us a page and a problem number.
It was 3, 4.
Okay. So we're on page 317.
Number 53.
318. Number 53. They give me an equation. It's number 53 on page 318. And And the equation they give me is this. And they say that this equation is the relationship between the intensity at a depth of x feet. So then they say, what is the intensity at a depth of 40? So we just plug 40 in there. And did you write down what that times 40 is? Okay, well, that would be our first step, is plugging in 40. Looks like 0.094. If I multiplied right? Oh, not x, I plugged in x. Now I need to solve this for I. Any ideas how we'll do that? We need to figure out what that I is.
You do 10 to the.
Exactly. The base here is 10. So we're going to say 10 to the negative 0.094 equals I over 12. And we'll figure out what that is and times it by 12. And that will be the answer. That will be the answer. Looks like 9.66. And that's, what is that, lumens? Yeah. Susie,
I sent you an email.
You did?
I know it's you putting those egg cartons, isn't it? Is it you doing that?
Yes, it is.
I knew it was.
Thank you.
You guys, Mrs. Ford, you guys know she's like the best baker ever.
Yes.
So like you were, oh, you bake for them?
Yeah.
Yeah, they've had a lot.
So-
We've had volleyball and football
Yeah.
and we the people and.
See, these are homegrown chicken eggs from the Mills farm, see, and I give them Mrs. Ford, and then every once in a while she makes me some. Aren't those the biggest?
Those are huge.
They're huge, aren't they? It's a big egg.
The big egg. These are awesome eggs.
So anyway, I put them in your mailbox, and I'm like, maybe you have a fridge down here.
I do.
So that's why I brought them down.
Thank you very much, Mrs. Mills. Welcome to Mathland, by the way.
Mrs. Mills on
Gosh,
special
we gotta get some real desks in here.
We like our
Is this it?
tables.
Really?
Each table is its own little collaborative community.
No way. You poor things. All right, see you later.
Mrs. Ford, I think she earns some extra credit.
Huh? What?
I think Mrs. Mills earns some extra credit.
Mrs. Mills is a sweetheart. She takes me skiing. None of my students will ever take me skiing, so Mrs. Mills takes me skiing.
Mrs. Ford, you go skiing?
Huh?
You go skiing?
Snow, or water skiing, not snow skiing, water skiing.
We do that
It's a
too.
little cold now.
I've seen some.
When the weather breaks again, I'll sure go skiing. I'll ski with anybody, anytime, anywhere. Except rivers, I don't do rivers. Don't ski on rivers. Okay, where am I? Oh, I finished that problem. All right, anybody else have a question about a homework problem somewhere along the line? Tonight, then,
I have a question.
yep, page and
Last
problem
night's
number.
homework- Last night's homework.
Okay, same page then, 318, 317.
I think it was like, how do you just like graph them for like 39, yeah.
39, log base 4 of x. And the directions say, describe how to transform it, then sketch it by hand and support the graph. Okay. The basic, when we talk about the basic family functions, the curve that you memorized, the equation, I should say, that you memorized, was y equals ln x, right? So the curve that they drew for you and you memorized was this specific y equals ln x curve. Now, every logarithmic curve looks like that. depending on the base, the curvature may be different, maybe, you know, flatter out this way, maybe steeper up this way, but that's the general shape of every logarithmic curve. But that's the basic one that you memorized. So it said, okay, this is going to have basically that same shape, but it's going to have some factor of either smashing it, making it more like this, or stretching it out, making it more like this. Okay? So you need to figure out what that factor is that's doing that. Is it going to shrink it down, stretch it up? What's it going to do? So this goes directly to what we talked about yesterday. I want to change this base 4 into a base E, right? So if you use your change of base formula, if you use the change of base formula, it's going to be ln x over ln 4. If you don't use your change of base formula, then you'll do it longhand and say, okay, 4 to the y equals x. Then I'll ln both sides, pull the exponent off, and I end up with ln x over ln 4, exactly what I had with my change of base formula. So this equation can be rewritten like this, which is 1 over ln 4 times ln x, if you just separate that fraction. Now, what's 1 over ln 4? It's just a number. What is that number? 1 divided by ln 4 is 0.72. So this equation is the same as 0.72 ln x. So in other words, you're taking your ln x curve and you're multiplying it by 0.72. Now, what impact is that going to have on the graph? If you take a point and you multiply it by 0.72, does it get bigger or smaller? So this would be a better approximation. This curve has been kind of flattened, shrunk down. The points have been lessened because you're multiplying by 0.72. Now, if you change that base to a 5, it's going to be exactly the same concept, only now this will be ln 5, and you'll have a different coefficient multiplying it. So every base is just a version of this. That's why they give you one. They say this is your basic family of functions. This is your basic curve. Every other base is just going to be a multiple of that. Okay? So you can't, on your calculator, graph this equation. You wouldn't be able to put this in, but you could graph this equation. All right, would everybody look now in your book on page 320, or 331, page 331? Let's see, I've needed my calculator a couple of times today, but most of the work I've done without a calculator. So we're going to look today at some more problems that can be done without a calculator, and then some similar problems where I would need a calculator. So are you looking on page 331? Let's look at a big scary problem like number 2. This is a frightening problem. This is a no calculator problem. Any ideas how we might start this no calculator problem? You should know how to start it.
Can you multiply or divide 32?
I want to divide both sides by 32. That's exactly what I want to do, Anna. So I have 1/4 to the x over 3 equal to 1/16. Divide by 32. You all right with that? Now what? You're tempted maybe to take the logarithm of both sides, because if you take the logarithm of both sides, you can pull that exponent off. The problem is this is a no calculator problem, and I don't think you want to be doing logarithms without your calculator. What do you notice? These numbers aren't random. What's special?
1 and 4 and 16 are squared.
Exactly. So this, I could leave this as 1/4 to the x over 3, and this I could rewrite as what?
1/4 squared.
Squared? So the key is that 1/4 and 1/16 can be written with the same base. Now, this is your common sense again. If 1/4 to this power is equal to 1/4 to that power, what has to be the case? They have to be the same. So x over 3 has to be 2, and x must equal 6. No calculator necessary because of this relationship. All right, so let's look at another one here. How about number 4? Any ideas how to start? Divide by 3, so 4 to the x over 2 equals 32. Harry, what are you doing?
No math.
Where did I go from here? If you find this problem out on your own somewhere, you can absolutely take the logarithm of both sides and do it, but if you don't have a calculator, what are you going to do?
Break it down to 2 squared.
You're going to notice that these are not random numbers. 4 is 2 squared, and 32 is 2 to the 5th. What do I do with these exponents?
Multiply them.
So 2 to the x equals 2 to the 5th, and x must be 5. Easy, easy, easy. Now, look at number 14. It looks the same. Structurally, it's exactly the same kind of problem. How would you start? What would be step 1? Divide by 80. So e to the 0.045x equals 3. What's different about that problem than this one? We're at this point right here. What's different about these two problems? You don't have a common base. You can't change e into 3 or 3 into e. You can't do that. So this problem, we have no choice. We have to use a calculator because we're going to have to do what to take care of this exponent? We're going to have to take the logarithm of both sides. And you can use any base you want, but since the problem involves e, we might as well ln both sides. What is ln e, that's log base e, of e to that power? What does this equal? 0.045x equals ln 3, so x equals ln 3 over 0.045. This is one of your properties, groupies. Log base e of e to a power is the power. Quit watching the clock. Time will pass, will you, Muleman?
So far, so good.
ln 3 divided by 0.045. I got 24.4, did you?
Yeah.
So tonight you'll have a chance to practice some of those. What I want to do now is have you turn in your packet to the supplemental word problems. It's the last page of the big packet. Now, these word problems are not in your homework tonight. Your homework tonight is solving equations like this the directions are very clear about whether you use a calculator or not. If you aren't allowed to use a calculator, what has to be the case? There has to be a common base, so figure out how to make it happen. Because if you're not using a calculator, you have to have a common base. Now, these next problems we're getting ready to do, there are a bunch of formulas, but I'm not making you memorize all of them. Some of them I will provide you on a test, and you'll just open up your book and get them out when you do your homework. But the two that you have to memorize, I think you've already memorized. Tell me if these look familiar to you. This one's referred to as the PERT formula. Remember that? No? Yes? Maybe? Who knows? This one? Remember seeing that? These are both growth formulas, or decay. They work both ways, especially that one. Growth or decay formulas, I call them growth formulas, because what's decay? Negative growth, right? So we've got growth formulas. This one compounds, so the growth increases. We think of it as compound interest, maybe, the easiest way to think about it. It compounds a finite number of times. This one is continuous compounding, or continuous growth. So this is the formula that we'll use, let's say, if we have a bacteria culture and we want to study the population of bacteria in that culture. This is the formula that we'll use, because this is continuous growth. This is the formula we'll use when you take your money down to the bank and you put it in and they compound quarterly. That means your money grows 4 times a year. That's not the way anything in nature works. Everything in nature is growing continuously. So if it's a nature problem, we're going to be using that formula, which kind of makes sense if you think about it, because this formula's got an E in it, and E is the base of the natural logarithms. Yeah, that's a natural situation. This is a man-made, these are man-made situations. So let's look at our paper. Some of these, especially the ones down at the bottom, we're going to need the other formulas for, and we'll talk about those maybe on Friday. But now let's look at number 1. How much would you initially have to invest at 3.125 annual interest compounded monthly to end up with $4,321 after 10 years? Now, first thing you have to do is decide which formula you're using. The first one. Because the key word in the problem is compounded monthly. Monthly means a finite number of times, right? 12 times a year. Yeah, you guys are going on the trip. You need to go. If this is when you're supposed to go. Somebody told me 8:40 and somebody told me 8:30.
We have to be at the room at 8:40.
And what room is that?
It's like all the way at the Red M.
Oh my.
Well, I mean, we're like leaving at 8:40.
Go, Angel. Go, go, go. Goodbye. I'll see you guys Friday.
What class is that?
I think it's in our village. Okay.
Hey, what trip are they going?
I don't know. They're going somewhere. Okay, listen. Now, in order to do this problem, we need to know what all these letters stand for. Does anybody remember enough of this from last year to tell me what any of this stuff stands for? Okay, R is the interest rate, right? And that is going to go in as a percentage. I mean, as a decimal, not as a percentage. That has to go in as a decimal. All right, what else is there? Well, yeah, that's going to be the number of years. Okay. A is the amount that you end with. That's the ending amount. P is the beginning amount. And it's called P because this formula is used almost exclusively for money. And the original amount you put into the bank is called the principal. That's why that's called P. Anybody know what N stands for? The number of times per year you compound. So the number of times per year that you compound. So if we are compounding monthly, N will be 12. And that N shows up in both places. So let's plug in what we know. How much would you initially have to invest? So what am I solving for? P. At 3.125, so 0.03125, annual interest compounded monthly, to end up with 4321 after 10 years. How does that formula look to everybody? Did I get all the numbers in the right spots? So 4321 equals P times this thing to the 120th power. Now, we are not going to need logarithms to do this problem. How do I know I won't need logarithms to do the problem? When do I need logarithms? When this is the variable, right? If that's not the variable, we're not going to do logarithms. We're actually, this is an easy one. We're going to type this in, right? And then what are we going to do with that number? We're going to divide this by it. So that's going to be easy. When you put this into your calculator, you should put all this in at one time. Don't write down a bunch of junk and round it off. Just put all that stuff in at one time. So parentheses, 1 plus 0.03125 divided by 12, parentheses, and then raise it using your little, that button, raise it to the 120th. Did you get 1.366? Okay, now don't write that down, don't round it off. Say 4321 divided by answer. And the answer button is right above your negative sign at the bottom. And that way there's no round off error, and you know you need to deposit $3,162.60. If you didn't get that, lean over to your neighbor, practice typing it in. Let's make sure you can type that in. Okay, everybody get it? We good? All right, keep track of which problems I'm doing here, because I'm going to skip down now to number 5. We sort of talked about this the other day. How long does it take to double your money if you invested at 3% compounded monthly? Which formula? Same one, same one. So I just need to figure out what I'm putting in where. Anybody see where to put anything in?
12 on the bottom.
12 is in, so that's 12, and this is 12. Okay. Interest rates, 0.03, that's here. What am I solving for? T, so my variable's here, that's T.
Should we put a 2 where the P is?
I can put anything I want where the P is. So I can put a 2 where the P is. If I put a 2 where the P is, then what do I have to put where the A is? A 4. Because what's happening in this problem? We are doubling. So could we have started with 5? Could P have been 5? Yep, and then I would have ended up with 10. we talked about this, kids. It doesn't make any difference because what's going to be step one of the problem? What are you going to do first? You're going to divide. And what's going to happen when you divide? That's going to be a 2. It doesn't matter what you started with. When you do the division, you're going to get a 2. Now, look where the variable is. What am I going to need to do to solve this guy? This is going to involve logarithms. LOG or LN, irrelevant, doesn't matter. I'll LOG both sides. What happens to the exponent? It goes to the front. So I have the log of 2 equal to 12t times the log of, I guess those parentheses, 1 plus 0.03 over 12. Now, before we go to the calculators, let's talk about what are we going to do this time? What are we going to do? How are we going to get t by itself? We're going to have to take whatever the log of 2 is, and we're going to have to divide it by 12, and divide it by this, right? Now, I round off error, anything that involves exponents, round off error is huge. So let's try to avoid it. Let's type this in. That looks like the hardest part. So let's type that in on our calculator. So we have the log of 1 plus 0.03 divided by 12. Okay, did you get 0.00108?
Yeah.
All right, so now this number is on my calculator. Don't we need to divide that number over to here? So let's take log 2 divided by answer. Now be very careful. When you do log 2, make sure you close that parentheses before you hit divided by answer. Did you get 277?
Yeah.
Okay, so now you've divided this over to here. The only thing left to do now is to take the 277 and divide it by 12. So the answer is it will take about 23.13 years. Got it? Okay. All right, let's look now at number 3. Number 2 is a tough one. We're going to have to come back to number 2 after we practice a little bit. But number 3, let's look at that one. Read problem number 3. And tell me which formula you're going to use. Which one? You're going to use that one right there. So let's talk about what these letters mean. Now the A and the P mean the same as before. So A is what you end with, P is what you start with. E is E. E is E. You guys got all excited, didn't you?
I was ready.
No, I saw the disappointment in your face. E is E, that's Euler's constant. His name's Euler, that's why it's called E. R is the same thing. R is the growth rate, growth constant. In a money problem, that would be the interest rate. It's the growth constant. And T is the time. Now, in this formula, T can have any unit of time. In this one, T is always in years. But here, T can be in minutes, T can be in decades, T can be in anything. For really unstable elements, T could be in like milliseconds. It could be a little teensy bit of time. All right, so that's the formula we're using. We're doing problem 3. What do I put where? 156 is what I end with. 92 is what I start with. E is E. 4R. Does that make sense to everybody? All right, step 1. Divide by 92. Now kids, do not type that in and write down some wacky decimal. Just leave it like it is. You're gonna use your calculators anyway, there's no benefit to having a decimal there, and you're just gonna have round off error, so just leave it be. Now what? ln both sides. And you're choosing the ln because the log base e of e to the 4r is just 4r. So you aren't even going to need to take your logarithm over there. You're just going to have ln 156 over 92 equals 4r. So r will equal ln 156 over 92 over 4. I got about 13.2% or 0.132 if you left it as a decimal. Now this isn't a money problem, but that's like the equivalent of the interest rate. That's how this thing's growing. That's 13.2% per what? Minute. Yeah, this is growing pretty fast. You ready to try one? At your tables? All right. Gracie, if you want to join a table, you can, or you can work solo, it doesn't matter. Let's take a look at problem number 4. Number 4. See if you can figure that out. Yeah, anytime it says continuously, you use the second one. The second formula, that's your continuous growth formula. Okay, it's kind of a challenge. This is a challenge problem. Let's see if you can sort it out. Did you guys pay attention that tomorrow you're supposed to wear the Stephen Vukovic shirts? You know, the level holds together shirts. Tomorrow everybody wears those. You'll find it.
Do you do this like a problem?
Oh, Mallory? Have you done anything? Oh, I got it. I don't know. What do you think? It's supposed to be problem solving. No, you're talking about something different.
So first we define A and then but like I think you just make up.
What's your credit was?
But yeah, you make up additional understanding. Because I didn't have that.
I'll do where your hair is at lunch. I might retract.
I think it's
Yeah, this
what did you come up with? Anybody come up with an idea?
It's wrong.
I stared at
It's
it.
wrong, well, let's see if